Good afternoon, ladies and gentlemen, and welcome to the European Space Operations Center here in Darmstadt to what I believe is one of the most exciting weeks, at least in my life, and I guess in your life as well. And this is the briefing landing minus 2 days, and therefore we want to give you an update of the current status of the Rosetta mission. And we've been inviting Andrea Accomazzo, he's the flight director, Sylvain Lodiot, he's the spacecraft operations manager, and there is also Matt Taylor, the project scientist of Rosetta, and the Philae lander manager from DLR, Stephan Ulmec. And with this, I would like to ask Andrea and Sylvain on stage and give us the latest status of the mission.
Thanks, Marcus, and welcome again to everybody. I don't deny that we are a bit tired, but we are also very excited. I think this is the key week of our professional career. I don't think we will land on a Comet another time, so I hope it's the right one. We've been working very, very heavily in the past months. We are convinced we've done all what we had to do and all what we could do for this operation. I think we've done it very professionally, at least this is my judgment. Maybe I shouldn't be the one judging this, but we've put all the effort we could do, put into this activity. There's still a lot in front of us. There are many things that depend on what we are going to do in the next couple of days. There are a couple of things that do not depend at all on what we are going to do. For example, when we touch down, we cannot select a single spot when we touch down. There we need to be a bit lucky. I kept making comparison with mountaineering because I like mountaineering. For me, it's like we are at Camp 4 of climbing Mount Everest. We want to go to the top and we want to come back safe. If we don't reach the top, it's because maybe the mountain didn't want us because the weather was not good. But we know we've done all what we had to do. We've done our best to prepare for this, and I'm convinced of this. Now, Sylvain will maybe give you a couple of details of what we are doing right now in this moment where we are speaking and in the next hours before we prepare for Wednesday. So thanks, and if you have any question later on, I'm available.
Thank you, Andrea. Please, Sylvain. Andrea, stay with us.
So, good afternoon to everybody. Just a few words on the spacecraft. So, spacecraft is fine. We've already actually loaded all the lander commands till touchdown. They're already on board. So, also the jet commands are already on board. Today we have planning. So, the flight dynamics commands, what we call the AOCS commands, are covered till midnight tonight. So, we are actually having a planning session right now. We're waiting for commands from flight dynamics. This will only go till the 12th of November at 4 in the UTC in the morning. We'll upload all the other instrument commands for that time period also tonight. And then the final commands for the last maneuver, all the last flight dynamics commands will go to the spacecraft just a few hours before separation, about 8 hours before, 7 hours before. So that'll be really, really tight for us. The lander is going on tonight at 18:05, if I'm not mistaken, and let's hope all goes well. We're starting shift work tomorrow, so with 24-hour coverage until over the weekend, basically. And yeah, as Andrea said, I think we've the two teams doing this shift work and flight dynamics have done a massive work in the last days, and I think we're ready.
Thank you, Sylvain. I'm always astonished, if they are excited or if they are nervous, it doesn't show at all. Stephan, update on the lander, please.
Yeah, good afternoon, everybody. So, as said already, the lander will be switched on this evening. We will start with warming it up, and then in the following hours, we will really prepare it for the separation and the descent. At the moment, everything is on go. The commands are uploaded, so the lander is ready to be ejected on Wednesday early morning and land later in the afternoon.
Thank you, Stephan. And of course, why are we going to a Comet? Because we're doing science. Matt, the latest status, please.
Yeah, we're going there because of people like me. Really, this week marks an epoch in the mission. There's been a massive focus for a reason, because these guys have got us there to the Comet, got us round the Comet, and got us ready as best we can, as has been said, to land on the Comet. Once this week has passed, we start full science phase is all about science then. Up to now, we have been doing science on the side, enabling landing site decisions and characterization of the Comet. We have science off the back of that, but really from this week onwards is where we start the main phase of this mission, from my perspective, and it's all go now, so stay tuned. It's very exciting.
Okay, and that already brings us to the question and answer sessions. If you have questions, please raise your hand and state your affiliation and all these kind of things. So, first.
Okay, Jonathan Amos, BBC. Andrea, can you give us an update on when precisely the pre-delivery manoeuvre is going to take place? What do you know about the timing of that event now?
Well, this was said earlier on by Sylvain. We will have a final orbit determination starting tomorrow in the afternoon. And only in the course of the day tomorrow, we will work out the exact time of this maneuver, the magnitude and the direction, because we want to see exactly where Rosetta is to time exactly the point where we separate the lander. This point is fixed in time, space, velocity, and attitude. And we have to reach exactly that point. So wherever Rosetta is, we have to design the maneuver to reach that point. This will take place tomorrow afternoon. So only tomorrow evening, we will know exactly when this maneuver takes place.
But you expect it, what, sometime around 6 o'clock GMT space time?
Well, now there are so many times around UTC, and we expect this maneuver to take place in the middle of the hour slot that we have given. This is our nominal time. We have to play. We can play with plus minus 30 minutes. So if everything goes well, we'll take place exactly in the middle of that slot.
But the burn is of the order of what, minutes?
I think it's 7 minutes.
7 minutes of burn.
Yeah.
Hi, Eric Hand with Science Magazine. I have a couple questions. We can come back to me later, but I guess my first one's for Andrea. Can you explain, so the release point is at 22 kilometers, 22 and a half, I think, but you orbited as closely as 10 kilometers. And I understand you had to get into a different orientation to be able to perform this special release maneuver, but can you explain why you chose this 22-kilometer release point rather than something a lot closer, because presumably if you were at 10 kilometers, you could have a lot more accuracy landing on the X.
Well, it's not exactly like this, but yes, there are several constraints we have to take into account when designing a maneuver like this. First, the 10 kilometers orbit were on what we call terminator plane, on the plane dividing day and night. And if we were staying on that orbit, the lander would land in those conditions. This is not what we want to do. We want to land in the morning on the day side. So we have to move the spacecraft in front of the comet. So this is one of the first problems. Second, we have a limited maneuvering capability of releasing the lander. The velocity we can induce to the lander at separation is limited. And this gives limitation in steering the direction where we shoot the lander down. And that's why we have to do it from farther away from the comet. Fundamentally, we want to fly by the comet at 5 kilometers distance and shoot the lander 3 kilometers aside. And if we were too close, we wouldn't have the capability to shoot the lander really 90 degrees away from us. That's the main reason why we have to do it from farther away. In terms of accuracy, this is not necessarily true, what you're saying. When we are flying lower orbits, we are much less accurate with the position of the spacecraft. At high altitude, we know much better where the spacecraft is, so we are more accurate actually in doing it in this way.
Hi, Ivan Semenik with the Globe and Mail newspaper in Canada. I know tomorrow there's a go, no-go point. I think there's more than one go, no-go, but I wonder if you could just explain what factors will go into that go, no-go decision. What will you be looking for and what could influence that decision?
Maybe I pass the microphone to Sylvain that has done the whole timeline.
Okay, well, the first one is at minus 13 hours. It determines if we have a trajectory solution for this final maneuver. Then we have run around minus 8.5 hours, is around midnight UTC, covering both the spacecraft go, no-go, and if we have the commands from flight dynamics for this maneuver. Then we have a lander go, no-go, minus 7 hours, and then we have a final go, no-go just before separation, just to make sure that the final maneuver was okay.
So just to follow, it sounds like all of those decisions have to do with the spacecraft's performance, not about say how the comet is behaving or anything about the comet environment.
It's fully on the spacecraft and the lander.
Thank you.
Any other questions? Sorry.
Hi, Yeah, Eric Ham with Science again. Early on, there was a lot of discussion about how we really don't know what the surface texture is like. It could be as hard as ice. It could be as soft as cigarette ash. But now I believe some of the instruments like Virtus are starting to gain some information about the thermal inertia of the material. So I guess my question is for Matt. Maybe you can tell us a little bit about what you've been learning with Virtus and the other instruments about what you're actually going to be landing in, the material properties.
Well, we know a little bit more than we knew before. I think some of the information was provided a couple of months ago from some of the first Virtus measurements, basically giving an indication of what the surface temperature was like, that it was a bit warmer than we first would think if we were looking at a solid ice, or to have visible surfaced ice. That's still the case, that we're still seeing those features even at higher resolution. There's some of the things that will be shown during this week and will come out in the next few months, because it's still under analysis. There's a lot of the data, it's not instantaneous, to try and pull out and tease out all of the information. So also to try and mix that data with the MIRO instrument, which is sub-millimeter, so actually probing below the surface to look at what the thermal gradients are. Deconvolving all of that data and adding it together is still ongoing. So it's still giving us an idea of that, yeah, it's a more dusty, porous-like material, maybe matching with some of the tests and some of the material that the lander was tested on. So as you're alluding to, between the kitty corals or that kind of material, hard-packed snow or the cigarette ash. So it's in there, the analysis that we're looking at, as well as the visual or the imagery we've seen, the visible wavelengths from OSIRIS, and that went into some of the site selection to say, is this material newly laden, or how thick this material is based on some of the images. It's still out there, really, to be honest with you, and still we're relying on some of the broad margins of tests that were carried out on the lander. And
are you seeing these dusty, porous characteristics largely across the entire landing site in a consistent sort of way?
Yeah, there's subtle variations, but I'd say when you look at it as a global view, that it's reasonably consistent across. We haven't seen massive, large patches of ice, for instance. It's still indicative that it is this porous, dusty-like material.
Any other questions?
Sorry, yeah. Stephan, what is it that tells you you've landed? What are the signals that we're waiting to receive? What is the data that tells us we're down and secure?
Well, we will get signals from the lander already during descent. But within these data, there is housekeeping values, including an information like the touchdown signal. That's a bit within our housekeeping, which is on board the lander, also used so that the lander knows we are there and triggers, for instance, the harpoon firing and the cold gas thruster firing. Immediately after this one bit, we also get information on the harpoon itself, a harpoon success signal, whether the harpoon has fired and anchored. And this tells us, A, we are landed because we have the touchdown signal. B, we still get signals from the lander, which is a very good sign already, because otherwise we wouldn't know we have landed. And C, we even get information on the status of the landing by having the housekeeping, for instance, whether the harpoons have been fired, whether the tether has been rewound. So this is the information we get. And this will take a few minutes maybe to really analyze and fully understand, yes, we are landed, yes, the harpoons are fired and safely anchored.
But if you sort of land in Eric's cigarette ash here and you sort of lift off again, you fire the harpoons, they don't secure, the screws don't secure, the thruster stops working because it's run for 60 seconds. You may still have radio contact, yes, with the probe.
Well, the thruster, in principle, if we do not happen to land on a very steep slope, that's where we have a problem. But in principle, the thruster would press us down to the surface, so the rebouncing would be only very, very limited, even due to some inertia by the harpoon firing. Now, if the material is very soft, we may well sink in a little bit, yeah. But the harpoons still should anchor in principle because they go into deeper layers where there is expected to be some harder material. If we completely retracted the harpoons after firing them, then we would assume lander has landed but is not safely anchored, which is somehow middle good. Good, we are landed, not so good, we are not anchored, which would cause problems, for instance, for drilling.
Right. So it actually could be quite some time then before you're able to confirm the status on the surface.
Well, as I said, this status, that will take a few minutes for sure to really understand what has happened. Are we safely on the surface? Yeah.
Sorry, Rob Little from BBC Sky at Night. Are you planning to drop straight vertically down, or will the lander have some lateral motion as it comes in at the end?
Natural in the sense that if you throw a stone, it's kind of a parabola, and you can imagine a little bit that's also what you do with the lander. You stop it in orbit, and then it falls down on actually an elliptic orbit which crosses the surface of the comet. So it's not straight down. That would mean that we fully would compensate the orbital velocity. Then you would fall down straight, but that's not what we want, because we want to compensate at touchdown the velocity of the landing site due to the rotation.
Hi, Shelley with Discovery Channel in Canada. You've talked a lot about the communication with the spacecraft and the lander that have to take place between now and the no-goes. Is there any activity, new activity that you're seeing from Miro or Virtus on the Comet that would affect your go, no-go decisions, whether that's jet activity, sublimation that's increased, things like that, that are have changed dynamically over the last couple of days?
Well, this is not really considered that we would now measure a complete wild outburst. I mean, it would have been something very, very dramatic. Nobody thinks of like the comet breaking apart, but well, that would cause us rethinking the landing on Wednesday. Yeah. It's a clear no-go. If the comet breaks apart, it's a no-go. It's in our list. Yeah. Well, actually, it's not in the list. I was cheating.
Okay, now that we got that question straight.
This is back, Ivan Semenik again, and this is back to the question about the uploading the software and the commands. Does that include the commands for the initial science observations? Has that all been planned out? And if so, how long does that cycle go before you start to steer it in different directions?
The first science sequence is already then on board the lander. So the lander knows what to do after the touchdown signal. However, also during this first sequence, there are again go, no-go decision points. And not only go, no-go, there is also possibility for modifications. We can modify some parameters. We can, in some sense, adjust to the actual landing site and the actual landing condition.
And how long of a time span?
The first science sequence is about 2.5 days until the primary battery is empty. And then we will enter the long-term science, which is a lengthy thing because we always need to recharge our battery with the solar generator, which would take a few days. And then we can have some operational run, and then we recharge another couple of days. So it's a completely different type of operations, these long-term operations.
Thank you.
No more questions. Okay. But thank you very much for your questions. I think they were very interesting. And thank you to the gentlemen that they found the time despite being really busy. We appreciated it much. Sylvain, Andrea, Stephan, and Matt. And the next briefing will be tomorrow morning at 11, then hosted by Jocelyn. And I hope I see you back. Thank you for your time. See you later.